one of the reasons that we started Skycoin was because of the inefficiencies in Bitcoin. So when Satoshi originally created Bitcoin, he intended to create a centralized cryptocurrency. And originally, the Bitcoin network was designed to run over hundreds of thousands of computers in different countries. So the idea was that instead of, you have a bank, and the bank can steal your money, and then the government will come in and do regulation and throw the people in prison sometimes, but a lot of times you can have your money stolen and nothing can be done about it. So the question was how to replace the trust in human institutions and governments with mathematics, because many countries don't have stable governments and stable legal systems. So for instance, in Africa, I was talking to an investor, and he was doing a gold mine, and you give the gold to the government in Africa, and they pay you money in the central bank. And he's like, there's no way my money can be stolen. I have an account with the central bank. And he sells the gold and puts the money in the bank, and then the employee at the central bank of that country stole his money. So in most of the world, or you have an account in Switzerland and you put in $10 million to hide it from taxes, and then the banker just takes your money and there's nothing you can do about it. So the idea behind Bitcoin was that the legal system would be enforced with mathematics instead of with lawyers and prisons. And to do this, you had to make a network that wasn't controlled by any particular group. So Satoshi originally envisioned Bitcoin to be distributed over hundreds of thousands of computers globally. But what ended up happening was, by the third or fourth year of Bitcoin, one or two mining pools dominated and controlled the network. And there was a point where one mining pool, gigahash.io, controlled over 60% of the Bitcoin network, possibly 70%. And they were even hiding the hashing power of their mining pool in other mining pools so that Bitcoin still seemed decentralized. And today, the whole network is controlled by Bitmain, which is, there's 3 mining pools in China, and the hashing power comes from ASICs produced by Bitmain, and Bitmain says you're going to get 20% of the hashing power, and you're going to get 25%, and you're going to get 26%. And they sort of divide the market up between 3 different companies. And so Bitcoin originally was designed to be decentralized, but became centralized. And so one of the reasons we started the Skycoin project was it became immediately clear after the launch of Bitcoin that it had failed, and that Bitcoin was not decentralized. And eventually, the miners who made money from the transaction fees would start injecting fake transactions into the network, and they would put in a fee on the transaction, and then the miner gets the fee back. So you see all these people paying $40 per transaction, $50 per transaction, and that was actually the mining pools injecting transactions with fees, and then when they mine the block, they get the fees back. And then the other users had to bid against the mining pools to pay $50 per transaction. And the mining pools made a lot of money because they forced the users to bid to pay the highest fee that they could. So that there was some conflict between the miners and this idea of decentralization. And another problem with Bitcoin is if you control the majority of the hashing power, you can revert transactions. So I can deposit a coin into an exchange and buy another coin, withdraw the coin, and then 51% attack the blockchain and get my money back. And then the exchange loses the money. So we wanted to eliminate the 51% attack. And so to fix these problems, to create an actual decentralized cryptocurrency and to eliminate the 51% attack, we spent 4 years developing a new consensus algorithm called Omnis. And another issue with Bitcoin is the electricity usage of the network is extreme. The electricity usage just for Bitcoin to do 6 transactions per second is enough electricity to power 300,000 houses. And so if you had 1 or 2 large coins like Bitcoin or Ethereum, proof of work or proof of stake would work. But in the future, blockchain is just a database. And blockchain will be used by banks, and blockchain will be used by farms, and blockchain will be used by all of the large internet companies. And one company may have several thousand blockchains, and they may have a blockchain for payroll, and they may have a blockchain for inventory, and they may have a blockchain for their coupon systems, and Starbucks might have a blockchain for doing gift cards or coffee coupons. And so we're going to see blockchain being used like a database, and so in the future blockchain applications, the way that the Bitcoin network is run won't work because it's just too expensive. And so what we did with Obelisk is we created a consensus algorithm that has a higher level of security, faster transactions, and which eliminates the cost of running the network. And we can actually, Bitcoin only does 6 transactions per second and it takes 20 minutes for a transaction to be confirmed. We're able to do a transaction in 1 second, and we're able to do 300 transactions a second. Ethereum does 30, and can do over 300. So every single one of our blockchains is 10 times faster than Ethereum. And since our consensus algorithm is very cheap to run, we're able to run an infinite number of blockchains with no limit. And each blockchain has a higher level of security than either Bitcoin or Ethereum. So one of the goals for building the next Bitcoin was we needed to get the transaction rate to be faster than a credit card. So when you go into a store and buy coffee, you don't want to wait 1 hour for your transaction to confirm. You want to walk in, you want to buy something, and then you want to walk out in less than 2 seconds. And so we had to design a completely new consensus mechanism to replace proof of work in order to get rid of the 20-minute transaction times in Bitcoin. And in Bitcoin, as you make the transaction times lower, you lose security. So we needed to create a completely new approach to the consensus problem. We didn't want to pay people $50,000 per block to create a block. If you can run our consensus algorithm on a cell phone chip, and it only costs you 50 cents a month, or a few cents per month in electricity, it doesn't make sense to pay people hundreds of thousands of dollars per block in coins just for making blocks. So in Bitcoin and Ethereum, people are used to being paid hundreds of thousands of dollars just for creating blocks, and it's not really doing anything useful. And so we eliminated the reward, the new coin creation in each block, because it was both the source of inflation and it created economic incentives for companies to consolidate the network. And so we felt that the block reward is against consensus. And so what we ended up doing then is we had to figure out a way to distribute the coins, because in Bitcoin the coins are distributed with each new block being created. In Skycoin, since we felt that the block reward was pathological, we created applications in order to distribute the coins across the network. So in Skycoin, in order to get the coins into the hands of the most people, we invented Skywire. In Bitcoin, at the start, anyone could join the network and run an application and receive coins for doing consensus. But over time, only 1 or 2 mining pools ended up doing all the mining, and the average person on the street couldn't participate in the consensus process. And so we wanted to create an application that millions or hundreds of millions of people could use in order to get coins. And so in Bitcoin, whoever has the most money, in Bitcoin and Ethereum, whoever has the most money controls the network. If you have the most hashing power, you control the network, and the person with the most hashing power is the person with the most money to buy equipment. And so this doesn't lead to decentralization at all. It leads to consolidation and to an oligarchy, which was what Bitcoin was designed to eliminate. And so the Obelisk consensus algorithm is very similar to what Ripple tried to do but failed. And the idea was before Ripple there was a thing called Ripple Pay, and each person would have a node identified by a public key, and each person would follow people that they trust. And then your node pulls the information from the people you're subscribed to, and then you publish messages to your subscribers, and the community together, all of the nodes comes to a consensus. And what we did was we developed a new system called a public broadcast channel so that we could see the consensus process for every node transparently, so that there's an accounting system. So we didn't try to eliminate attacks on the network because it was actually mathematically impossible. If you eliminate attack A, it makes the network weaker against attack B. And if you make the network resistant against attack B, then it becomes weak against attack C. And no matter what you do, someone will always find a way to screw it up. So what we did instead was made the consensus process public. And then if someone attacks the network, anyone can see that, oh, that node is attacking the network. Oh, he's attacking the network, or that person's attacking the network. And so by making it accountable when the network is attacked, regardless of what the attack is. The nodes can be identified, and then people can start removing those nodes from the trust list and negating the effect that the attacking nodes have on the network. And the other innovation we made is that the miners, regardless of how much hashing power or what percentage of the network the attacker controls, they cannot actually do any damage. So we designed the consensus process so that even if the network is completely controlled by a malicious entity trying to attack the network, they can't do anything. The only attack they can actually do is slow down the network. If someone doesn't have your private key, they can't spend your money. So even if the network goes down for a day, the next day your money is still there and they can't steal it. So that's one of the, and then everyone else gets rid of the attacking node, and then the network operation continues. So those are the two key innovations. Not necessarily solving the consensus problem, but allowing people to deal with the problems when they occur, and allowing the identification of the attacking node, and eliminating any economic incentive that nodes have for attacking the network. Because in Bitcoin and Ethereum, there were many cases where nodes actually made money attacking the network. And so in Ethereum they said, oh, we'll just pay the attacker so that he makes more money from not attacking us. But then paying the attacker doesn't make any sense. So we didn't do that. So the public broadcast channel is the new cryptographic primitive we developed to allow public accounting of the consensus process. And what the public broadcast channel does is it ensures that a node cannot say one message to this node and one message to this node. If someone publishes a message, they sign it with their private key, and it is replicated peer-to-peer, and there's no way for that node to say one message to A and one message to B. Every message they publish is now public, and it's replicated peer-to-peer, and if they publish two conflicting messages, it can be instantly detected. And so this cryptographic primitive is what allows us to solve the Byzantine generals problem and achieve consensus without proof of work. And so if a node starts disobeying the rules, since the public broadcast channel allows us to see the activity of every node on the network, if a node starts maliciously attacking the network, people can just start removing them from the network. So this consensus process is very efficient. We think that there's not going to be one blockchain, but we have a platform called Fiber, so we have an infinite number of blockchains in parallel, and each blockchain can do over 300 transactions a second, and in the future that'll increase, but that's already 10 times faster than Ethereum. And so if we have 10 blockchains, we can do as many transactions globally as Visa does for global credit card payments. Skycoin was designed so that the attacks are trivial, and it was designed so the energy consumption of the consensus process is extremely low, and the network is very cheap to run. And this is as important as we go to millions of blockchains. We eliminated the transaction fees so that people couldn't abuse the network and try to hold the users hostage, because the Bitcoin transaction fees eventually reached $50. And people, in the beginning, they started using Bitcoin because I started using Bitcoin because it was cheaper than sending money through a bank. So if I wanted to send money overseas, the bank would charge me $50 or $40. And then if I wanted to send money overseas with Bitcoin, it would only cost a few pennies. And so I started using Bitcoin to send money overseas and for transferring money around. And then eventually the Bitcoin transaction fees reached $50, and using Bitcoin became more expensive than the bank. And then and the miners, of course, made money on this, so they didn't want the problem fixed. So in Skycoin, we decided that to eliminate the transaction fees to stop people from fighting over control of the network in order to get the transaction fees. And the other thing is to make Skycoin faster than credit cards. Instead of having transactions take 1 hour. And this low energy consumption is extremely important for what we're doing next year and for the next generation of blockchain applications, because we're starting to see people ask, what is blockchain? And blockchain is basically a database. So in the future, we're going to see thousands of different companies using blockchain, but they're not going to have coins. They're just going to be using blockchain for storing data, and blockchain will be used to replace SQL databases. And in Delaware, in the United States, the government has made it legal for companies to put their stock on blockchain. So if you have a small company, from day one, that company's stock will be on the blockchain, and it'll be an asset that can be bought and sold. And there's going to be tens of millions of companies incorporated, and many of them are going to have their stock on a blockchain, and many are going to want their own blockchain. So instead of having 1 or 2 large blockchains like Bitcoin and Ethereum, we're going to have millions of smaller blockchains that are being used for a single application. And so as we move into the future of blockchain, being able to do consensus at a low cost and with low energy becomes more important. And then for adoption today, even if you build a coin that is vastly superior to Bitcoin, it's not enough. There has to be a reason for people to use it. And so what we focused on with Skycoin is we focused on applications that millions of people will use. So we focused on Sky Messenger and social media applications and Kitty Cash and video games on blockchain and Skywire, which is Skywire is very interesting because it's a decentralized telecommunication company on blockchain. So instead of an ISP owning all the equipment and installing all the equipment, the community goes and buys wireless access nodes and installs them, and they connect to each other. And if you provide bandwidth to the network and you forward packets, you're being paid by your neighbor. And if you provide bandwidth for your neighbor, he pays you. And then this concept was then extended to energy grids. So we have solarbankers.com and we have Apollo Energy, and we have several companies that are now trying to do blockchain power grids. So if you produce electricity and your neighbor buys it, you receive coins, and if you use electricity from the grid, then you pay coins. And so we're seeing this year the development of token economies. And these are one of the applications that we developed, Skycoin and the Fiber, which is our infinite number of blockchains in parallel, in order to address. And so Apollo Energy is partnered with one of the largest, it's a Chinese company, and they are partnered with one of the largest solar companies in China, and they're working on a pilot project in Australia to use to build a blockchain-based power grid system. And we have several, and also a large company in Portland that we're going to be working with to develop that. And so today, it's not enough to have the best blockchain and the best consensus algorithm and the fastest transactions. You also have to have reasons for people to use the platform and to use the coin. And we're in the beginning of blockchain, it was completely speculative. People were just buying coins because the price was going up. So it was just completely speculative assets like Beanie Babies or tulips or stock speculation. So it was really, blockchain for the first 6 years was based upon just people gambling about the price of coins. And in the next 2 to 3 years, we're going to see the first corporate applications of blockchain, and blockchain moving away from tokens into becoming something that is actually useful and that will be used by corporations. So for this year, we are launching Skycoin, and we're launching getting the consensus network up, and we're launching major applications like Sky Messenger and the Sky Miner. And so Skywire is the first big application that we're announcing and launching. And then over time, we're going to launch additional applications. Like towards the end of the year, we're going to launch a blockchain power meter, and we're going to be launching a hardware wallet, and we're going to be launching several hardware projects. Towards the beginning of next year, we're launching this programming language, which will be in the forefront of marketing. And the idea is we have blockchain as a database, so we built the database, but then businesses have business logic, and they have things like smart contracts or programs that they want to embed on the blockchain. And this is CX is our blockchain programming language, which we're going to have a lot more to talk about next year. When we were working with Bitcoin is in C++, and if one developer makes one mistake, you can have 60 developers working on a project, and if one developer makes one mistake, he doesn't check the length of an array, then that can result in an attack, and someone can send a packet to the server, it parses the packet, and then hijacks the program, and then they can steal all your coins. So C++ isn't memory safe, and is very dangerous to actually program in. And this is one of the reasons why only 3 or 4 people are actually developing Bitcoin at any time. So Skycoin, we were one of the first users of Golang. And in Golang, if a programmer makes a mistake, the program can be crashed, but no one can hijack the program and steal your coins. So Golang is resistant to remote code execution. But the other thing is determinism. So if you're doing blockchain programming, if you have 100 computers running the same blockchain, if 2 computers run the same function with the same input, they should always get the same output. But it turns out this isn't actually the case. So a 32-bit computer gets a different result than a 64-bit computer, and an AMD processor gets a different result from an Intel processor, and different versions of the same compiler on the same program on the same CPU will give different outputs for the same input. So no computer program is currently deterministic, and this is a huge problem if you're doing aircraft or missiles or satellites where you put something in space and then there was a bug and there's $10 billion satellite doesn't work anymore. And the solutions for this are extremely costly, and so what we wanted to do, and so this is a big problem for blockchain, and you see a lot of problems with, on Ethereum, smart contracts. Every week another $20 million is stolen, or $60 million, or $120 million, and you have a DAO hack every single week, and it's been going on for years, and no one's been able to fix it. So when we said we wanted to do a programming language for blockchain, we said we wanted to fix these problems. But at the same time, if you use a very specialized language that is safe against these errors, then it becomes very costly to develop. It could require 20 times the cost of a normal programming language, and then you have to train people to use just that specific language. So with our platform, we basically designed a programming language that is secure, and that is fast, and that has determinism, and which looks like a normal programming language. So if a company wants to put their applications on blockchain on our platform, they can take any Golang developer or C programmer or Java developer or C# developer, and within a few minutes that person can start writing blockchain applications. So it basically looks like Golang. And we have a debugging prompt, and we have a test environment now, and you can start writing applications in CX and testing them. And what we're going to be doing with this later in the year is we're going to be doing university partnerships, and we're going to be training students how to we're going to have workshops and have students come in and have them do blockchain courses and start training up students how to do blockchain applications on CX. And then we're doing hackathons, and this year we're starting development on video games and Kitty Cash and blockchain poker and sort of demo applications. In a normal programming language, you run the program and you don't know what it's doing. It's running, and the user has no way of seeing what's going on. In CX, since this is designed to be embedded in the blockchain, you can actually go into the program and see what objects are there, what data there is, how many objects there are, how much memory they're using, and the user can actually go into the program and see what it's doing, which is very important for debugging, and also very important for the blockchain applications where the users want to know how much memory each application is taking and how many objects there are, and inspect the state of the program. You can take the program and you can serialize it as a byte array and then send it to another computer and resume execution on there. And we have determinism, and every object has a standard way of serializing it and then sending it over the network, which this should be a feature in every programming language, and it's necessary for blockchain programming, but it is not supported by any language that I know of. So we actually had to write our programming language to get this. And then we have a notion called an affordance. So if I have an object, for instance, a smart contract, and I have a function, I don't want everyone calling that function in the world. I want to say, only that person can call the function, or if you want to call the function, you have to do this, or no one should be able to call the function. So in CX, we have a thing called an affordance, and we have a set of operations, and the affordance formalizes who can call what. So in the DAO hack in Ethereum, people deposited money into a smart contract, and then someone called a function to steal the money. And they shouldn't have been able to steal the money, but there was no way to stop them. In CX, we actually have an affordance, and unless you say that a function can be called, and by who, they can't call that. So this is extremely important for security and to make sure that you don't have your money stolen when there's a smart contract. And affordance has also let people update smart contracts. So one of the problems is if you have a power company and you are running your power grid on blockchain and your smart contract has a bug, there's no way to fix it. There's no way to update the smart contract after it's been created. So we can add, I think, an affordance, and then we can say who's allowed to update the smart contract. And so if there's a bug, they can then go and fix the bug. And this is a major problem with Ethereum, which is after the smart contract is launched, no one can fix it. So we designed this so we can avoid that. And we have a thing, cx.skycoin.net. You can actually go onto this website and you can run CX programs in the web browser. And so we have Hello World, and we have some example function, and it looks very much like Golang. Like you have a struct and functions, and then a main loop, and you have packages. So any developer of Golang or C# or Java can quickly, within 10 or 20 minutes, start developing blockchain applications on CX. And this is like an example to do Fibonacci numbers using affordances. And this can also be used for AI and machine learning. So in this case, I have a function. I have a bunch of dots or points, and I want the computer to create a function that models those points. So I don't tell it how to do that. I say, here's the problem I want you to solve, and then the program can try random things. It can apply affordances until it finds a solution, and it can actually evolve new solutions to problems. And so this is, so for AI, and for biology, and for machine learning, there's a lot of, these language features are very useful. So if I give it data and I say, computer, predict what this thing is going to do, the CX language can, a package can automatically try to apply different solutions and then choose the one that best solves the problem. And this is something that you can't do in other languages. And then we're starting to do video games. So we just, a few months ago, just added OpenGL renderer. So you can now have a, like a poker game or a little video game or we have like robots that go around, like little AI bots, and then we can test different types of AI programs on them to see how well they play in these video games. And then we have things like blockchain Tetris. We just wanted to show an example of a video game. I think eventually we can even do first-person shooters on blockchain or SimAnt or like poker casinos, and we're going to start adding different video games. And we're going to have hackathons and bring students in, and each student will spend like 2 days developing a video game. And then we're going to put, eventually have an app store, so people will be able to upload their CX apps into the app store, and they'll be able to also upload their blockchain applications into our app store, and people will eventually be able to buy things in the apps of coins. And then eventually Kitty Cash will be on CX too, which is one of our flagship applications.